Welcome to the Chesapeake chapter presentation this evening. We have Sandy Friedenthal talking about the future direction of SysML. I'm Gundar Zazwal, the program director. 20 years ago, Sandy, we were just talking, UML was first approved by OMG. And at that time, us software people said, because I was a software guy and a system engineer, we said, well, we really need to have system engineering tools. And how are we going to get system engineering tools when the management doesn't really want to buy all sorts of extra stuff for the system engineers? So we said if we just piggyback off of UML, add some features to it, then maybe we can get in there, sneak in there before everybody knows. So that's what started out, the SysML, and now we're doing SysML version 2. I know I saw a couple years ago, Sandy had started it off, and he had a wish list of about 20 items that would seem to be really interesting yet very difficult to do. So we want to see how far he got and where he's going with that. Sandy?
Okay, thank you, Gundar. Thanks for having me. Directions for SysML v2. We are currently working on the requirements for SysML v2. And this is being done through the Object Management Group, the OMG, which is also responsible for, as Gundar said, SysML and UML. We will basically be issuing the requirements in the form of an RFP. This is through the OMG process at the end of the year. And then after that, after the requirements are issued, then you form submission teams and you actually start working on the language. So we don't have the language right now, the SysML v2. We have a lot of concepts that we think will get into that language, but we're focused on the requirements right now. What I'm going to do is give you a little bit of background, and I'll talk to you about those requirements and just a brief summary. If you have questions, go ahead, ask them. If I can handle them in real time very quickly, I'll do that. Many of them, if they're a little bit longer, I'll just defer them to the end of the session. So I mentioned we're working this through the OMG. These are some of the contributors to the requirements, their company and individual names. So all these folks have been contributing to the development of the requirements. We've got a pretty broad base of users as well as tool vendors involved. So it's a good group of folks. And background. So SysML v1's been out for over 10 years now. It originally came out as an adopted spec in 2006, formally released as version 1 in 2007. And so it's been out there for quite a while. So that's over 10 years. So over that time, I mean, when we started, SysML as a language was immature. The tools were immature. We've made a lot of headway since that time. The specification itself has evolved. We're currently on SysML v1.5, so they get incremented in .1 increments. So we started with version 1, then 1.1, et cetera. And we're working on version 1.6 right now. So this is going on in parallel as we develop the requirements for SysML v2. So work isn't stopping on the v1. We'll just continue to evolve and hopefully improve v1 as we develop v2. I think over that period of time, I think it's fair to say that the adoption of SysML has really helped to facilitate the awareness of MBSE. I think it's really enabled that. It's also very fair to say, I think personally, but I speak for the broader community, that we've learned a lot in terms of what works, what doesn't work, and in terms of applying MBSE, in terms of deploying it into organizations, all of those kind of things. There's been a lot of lessons learned. And so that has really positioned us well for this goal to basically develop the next generation of SysML v2. And when we talk about this, we're not talking, I mean, if you look at SysML V1, it's been out there 11 years. By the time we get this thing, V2 comes out, it'll be 13 plus years. So you look at this for, we're going to live with it for another decade, 10 to 15 year time frame. So that's how we're thinking of SysML V2. It's not just for next year, it's for the next several years to come. So if we take a step back and ask ourselves, you know, what we've kind of the focus for SysML over these last several years, I'll just use this chart just to highlight a couple aspects. The first is many of you may recognize the 4 pillars of SysML V1 in the center. And what I'm highlighting there is just that we've learned a lot. We've matured the practice of modeling. And I think folks like Joe and Terry, I think, can attest to that right here at APL. But I think that's true across, you know, across all the different organizations. So we've learned a lot on how to do system modeling with SysML to support MBSE. But the other emphasis has been sort of around the boundary there, around the peripheral, and basically how to integrate SysML with other models and tools. And that really, when we started, it was important to us back then. But if you talked around industry, that wasn't the central theme back then. There was MBSE, and then sometime later we really started recognizing that, you know, this is just part of this bigger ecosystem. I mean, that's not new, but we really started putting emphasis on it. So SysML and the system model is one component of a much broader set of engineering models and tools of a total ecosystem. As we go forward, that's front and center. We have to recognize that this is a model as part of this broader ecosystem, which sometimes we call model-based engineering, or the model-based engineering environment. This was a slide I'm sure many of you have seen. It comes out of an NDIA report back in 2011, and I think it stands the test of time. This report was again, it came out of the Modeling and Simulation Committee that was led up by, at that time, Jim Coulihan, who used to be an APL person, retired from APL. But at any rate, he chartered a working group to look at model-based engineering and look at the risks and define what it is, look at the risks, look at the benefits, look at the to-be state. And this kind of characterized the to-be state. It's very, very simple, which I like. I like simple things. Basically, you see this life cycle moving, you know, diagonally from lower left, upper right, and you have this team working on the concept for a new development. And you have all the different disciplines, you know, represented. And the key thing here is each one of those disciplines has their own set of models and tools. And the system engineer is can you see that? Yeah. You can see it? Yeah. Okay. But at any rate, the system engineer is sitting there at the table, and they have kind of a unique role in that they serve to integrate across the different disciplines. That's pretty fundamental to system engineering, is that multidisciplinary integration. So they're using the system model as not only to architect the system, but also to glue together the other different models that folks use. So that's the basic role of system engineering, the system engineer on a development. Now, they build this model, which is indicated by that little helix there, and as they move from phase to phase, they evolve the model until you develop and deploy your system. And then these models basically can be reused across on other programs if done properly. So it's a pretty simple concept. The idea of working as a member of a team at this virtual table and bringing your systems engineering and domain expertise to the table. The other key component of this very simple vision was this notion of a collaborative foundation that enabled all the other folks in the enterprise to access this model data, to contribute to the model data for that matter. And at the time, we just referred to it as a collaborative foundation that consisted of governance, it consisted of technology, but it basically was a way in which other stakeholders could participate in that development process. And I think what's evolved over the last several years is, at least in my view, that collaborative foundation could be thought of as your product lifecycle management environment. That's a way to think about it. Different people will view it differently, but I don't know if you all are familiar with product lifecycle management, but I'll say a quick word about it on the next slide, or a couple of slides from now. So this overall environment that we were just looking at that supports all the team members, you could call that the model-based engineering environment. But the system engineer uses a slice of that environment. And we call that slice, that systems view of that overall environment, we call that the systems modeling environment. We've used that term. So system modeling environment is a view of the overall model-based engineering environment. And it's the environment that the system engineer, it's the environment that the systems engineer interacts with to do their job. So they're doing their system engineering in a model-based way. They're interacting with this system modeling environment, which is just indicated by their computer, but it's all the infrastructure behind that computer. And so we used this. One thing we did a little bit differently with SysML v2 versus when we developed the requirements for SysML v1 is we really tried to drive the requirements from the perspective of that system engineer interacting with this system modeling environment. That was pretty fundamental. So one of the things we did early on was sort of develop a concept for that system modeling environment. And out of that, we identified some capabilities. And so these are the capabilities that the system modeling environment provides. SysML v2, we want to support those capabilities. So what are those capabilities? Basically, they're things like model construction, model visualization, model analysis, model management, model exchange, support for MBSE collaboration and workflow. Those are the capabilities. What you don't see on there is specifically requirements analysis or architecture. That's not what the system modeling environment does. The system engineer does that, but the system modeling environment doesn't do that. So a lot of the requirements we actually drove from, for SysML2, you'll see a set of requirements that are intended to support those set of capabilities. And I'll say more about that in a few minutes. So the scope of this modeling environment, the system modeling environment, is shown there. It's the SysML language and tools. It's the various model libraries. It's the integrations with other engineering models and tools. And it's the customization environment to adapt your modeling language and associated tools to your needs, which may be a particular domain or some particular aspect of system engineering. I wanted to just highlight a couple aspects, again, in the context of model-based engineering and where the system model sits, or at least as it pertains to SysML. So what you see here is the system model up at the top there, and you see that it says it specifies the product definition data. So I've always viewed SysML, and that's not universally shared, but I've always viewed it as a specification type language, meaning it does architecture. It's a more abstract language, and it's used for specifying systems and subsystems and components, basically elements of your system. Use it for specifying things. It is not intended per se to capture detailed design data. Now, there's plenty of detail in the specification language, but it is not, for example, if you had a temperature profile on an engine of your car, I wouldn't use SysML to capture that. That's way too detailed. There's thermal analysis tools that do that and capture that kind of data. Now, it could refer to it, but it wouldn't per se capture it. It's not fundamental to the language. So on the other hand, a critical a max temperature on your engine would be a key property that I would expect to see in the SysML model, but not a full thermal profile, as an example. So the actual detailed design data is in that product definition. And then, of course, the product definition further specifies the manufacturing processes and the process definition and the like. So there's a ton of data there, and that's where I see SysML fitting in. The PLM environment that I mentioned on the 2B state on that previous slide shows that it has two primary functions. One is the data management, configuration management of your design and the associated data, and the other one is the workflow management. So the system model coupled with PLM is really a nice complementary set for integrating your data and managing the data throughout the life cycle. So I'd just like to point that out, because where does the system model fit in this broader context of MBE? This is one way you could think of it. Now, you also could ask the question, well, what does it really bring to the party? I mean, if you look at traditional, if I was talking to a traditional person who's very familiar with PLM or PDM, it's pretty much been CAD focused, mechanical design type focus. And so of course it's broadened out over the years, and there's been a lot of emphasis on connecting product definition data to process definition. So that's been a major focus. Now, all the PLM vendors are starting to look up, and they're starting to see the role of the system model in all this. And I think that's interesting. But what does it bring to the party? The system model brings a lot more abstract information than you would get normally in that product definition. So I just highlight that here. I mean, some of this may be captured, has been captured, but just generally, this is the kind of data, functionality, interfaces beyond mechanical. So for example, electrical interfaces, information about your environment, your natural environment, technical performance measures, traceability kinds of information. So this is the kind of data that gets augmented along with the basic specifications, which are indicated by the requirements there. So as we go forward to SysML 2, my personal view is it's going to continue to look like, it will be like this, but hopefully work better and better over time. The other really key aspect, you got to manage the data. You also have to integrate the data. And PLM has not been a mechanism to really do a lot of data integration. It integrates it sort of at a file level. But we need a lot more integration at a much more granular level if we're going to do real traceability across the engineering environment, across a set of models. And that's what's indicated here by Axel Reichwein's slide. He's showing requirements tied in with test cases and the architecture, simulation model maybe in Simulink, and your CAD models and software models, all this stuff, but it's connected at a very granular level. And I mentioned a lot of emphasis has been placed on this integration. And so there's actually a lot of progress been made to move in this direction. But again, as we think about SysML 2, it's got to support this kind of notion, this approach. We need this granular level of integration going forward. So I'll say, with that as a little background, I'm going to go now into the requirements approach. What are we trying to do? What we want to do is facilitate not only a better language, we want to facilitate adoption. We want to get a broader base of folks. A lot of companies and organizations use SysML, but it's still usually a relatively small pockets of people within the organization. By no means do, most system engineers are not practitioners of MBSE with SysML. So there's a lot of room to grow in the adoption side. But in order to do that, we have to address things like usability, and we have to make this language more usable. And at the same time, we have to make it more effective. And there have been, as I said up front, we have a pretty good handle on what we do well and what we don't. So I think we know the directions to go to make this language better looking forward. But I kind of focus on 3 areas here. The first one being precision and expressiveness. This is one of the first things we want to improve. Expressiveness means we want to be able to say more things in the language. So for example, you'll see we have requirements in here for improved support for variant modeling. So SysML has some support, but we want to have more support for variant modeling. So that would be an example of, let's say, being more expressive, more concepts. But more precise is really important. And over the years, we've heard lots of things about our precision. We're somewhat precise, and it's always hard to get a perfectly, like you can imagine, if this was completely mathematical based and everybody was working with set theory or something like that, we wouldn't have any adoption, right? So if all we had was a bunch of mathematical equations, it'd be very precise, but it wouldn't be usable, if you will. So we have to achieve that balance and try and get the precision. I think precision is going to get much more important in the years ahead. And the reason I say that is we see early adopters, folks like at JPL, for example, where they're trying to use these models to, what they say, reason about the system. And in order to reason about the system, you're basically doing logic you've got this model and you want to infer things about your system. And so you need this precision of logic in order to do that. And it's very non-trivial. And so that's an area that, particularly looking forward, where we're going to need more precision as well as expressiveness. Interoperability with other engineering models and tools. That's foundational. Again, we've come a long ways, but we got a ways to go. And then usability, for the reasons I said, to get the adoption. And when we talk about usability, it's by both people who develop the models and people who just consume the models. So there's usability on all sides. So what we're doing is, number one, for that first bullet there, precision and expressiveness, we're really working on an improved data model. It's got similar scope to SysML, but it's V1, but we have extended it in certain areas, and I'll show you where in a moment. It's now based on industry standards that weren't available when we did SysML V1, so we have things like 15288, we have the SEBOK, we have Incose handbooks and things like that, so we've tried to leverage those to provide a framework for the data model. We're no longer completely constrained by the UML data model, which is very complex and has a lot of software considerations built into the language that we tried to relax on the system side. And we're trying to ground it, better grounding in these logical formalisms so we can get this precision. The second bullet here, primary bullet, is addressing, I'm focusing on that relative to the usability thing. One aspect of usability, when you think about it, is how do you construct the model? So I mentioned model construction as one of those capabilities. So you can make it more usable if people can construct models more easy, if it's more intuitive, if it's easier, and what have you. So we're looking pretty hard at model construction and saying, what can we do to make this more usable? Yes?
Question?
Yeah.
When you say grounded in logical formalism, are you thinking about things like data
We're basically talking about a declarative semantics that we're grounding this in, and that's pretty much it. It will have some, set of axioms, and it will be very grounded and basic, more or less formal logic. That's what we're talking about. And then so there's the model construction side from a usability perspective, and there's also the visualization side, and there's an area where we can do an awful lot. And again, we've seen extensions of the tools where the visualization is much more engaging and much more intuitive beyond our 9 SysML diagrams, way beyond that. So we're trying to take that to the next step. And then the third thing we're doing is we're introducing a standard API to improve the interoperability aspect and to enable other tools and models to access the SysML model in a standardized way. So we've had a standard for model interchange called XMI. That, frankly, has been fairly limited. This is a completely different level of interoperability. It's dynamic exchange through an API. All the tools have APIs, but they're not standardized. So we're really looking to try and standardize the APIs, and that will be potentially a really big deal. And, of course, we haven't had that at all in SysML v1. So that's how I would sort of characterize some of the things that we're doing. Now, I'll go into drop more detail in the next few slides. Any questions or comments before I go forward? Let me check my time here. Yeah.
I'm on a team which just recently tried to import a Rhapsody model into a Magic Draw tool using an XMI file, and we failed.
Yeah.
And I suspect maybe that's one of the weaknesses you were talking about.
It is.
Is it, and will this address that?
Yeah, the API is the way we look for the exchange. We also intend to have a neutral file format like an XMI. And we think by some of the things we're doing, we can substantially improve the ability. There's been a lot of work at the OMG to take a hard look at that, why it's failing. And I think they pretty much know that right now, and there's reports on it and what have you. And I think we have the opportunity to address that. But I would say more fundamentally, going with this standardized API is going to be the thing that you would use to integrate your model in an engineering environment. You would use file exchange, for example, if you stored a file for, and you had a program and you retired the program and you had long-term persistence, and then some day later you come and pick that file up and you bring it back up. That might be the way you would use the file exchange. But an API would be used for day-to-day dynamic exchange. Okay? So this slide just highlights sort of our specification development approach. If you're not working on the spec, I don't know if it's real interesting, but it's useful to just get a sense of how we're approaching it. So let me do this. So we actually started with some use cases for really, it says MBSE, but really they're SE use cases in a model-based way. And we went so far with that, we found that to be very intense, a lot of work. And we made some progress, but we kind of truncated that effort. But we did use it to derive those basic capabilities that I mentioned previously, which you see up there, the construction and the visualization. So those are the capabilities we're asking of that environment. And then based on that, we derived what we call these service requirements. And basically, these are going to be standard requests of this system modeling environment that gets realized to the API. So this is the requirements on the API, basically. And so if we want to, I'll just make up one, but we have these service requirements defined right now in draft form. But just let's say with visualization you had a service to zoom in, for example. So that would be a model visualization service, or to pan, or to do something along those lines. Those aren't exactly what we have, but I'm just using that to kind of illustrate. So, and model analysis, you might have some set of services to help you set up an analysis, for example, and then to execute the analysis, and things of that sort. So there's a whole set of services that are needed to support those capabilities, and we've specified those in the form of a set of service requirements. And those are part of our RFP, our requirements. The other part is the data model component, and that's illustrated here in the second icon. So if you look at that, and that basically has the concepts that, for example, we have in SysML v1, hopefully substantially improved in SysML v2, but concepts of structure and behavior and things of that sort. So those are the two fundamental components of SysML v2 that we're specifying. A set of service requirements that would allow you to access that data and do those certain functionality on that data, and the basic concepts of the language. And I'll highlight a little bit on those concepts. I'm not going to go into much detail. We don't have time in a short presentation like this. So what we'll do is these requirements will actually get issued in the form of a SysML v2 RFP. This is part of the OMG process, and it's fairly rigorous process. So the requirements that are right now out in draft form, they're out for review right as we speak. And that RFP will get issued at the end of the year, and then submission teams will form, and they will respond to the requirements in the RFP by developing the SysML v2 spec. And that's where you'll actually have, here's the Metamodel, here's a profile, here's your standard API, here's some other elements of this language. So this is the thing that it's a document, and that's the thing that basically specifies the language, and SysML too. And vendors implement that. So all of your Magic Draws and Rhapsodies and all those various vendors, they implement, like right now, there's a SysML v1 spec. We had a SysML v1 RFP back in 2001 and 2, 3. It got issued in 2003, and the spec came out in 2006, and vendors implemented it, and away we went. And now we're kind of repeating that process.
Sandy?
So this is how the process works.
Question.
Yes,
Are you going to have somebody check that the vendors properly implement their spec?
We have what are called conformance levels, and we'll have test cases that will be, if you look down there, it says conformance tests. So we're going to have specified test cases where a vendor would perform a test, a predefined test, and you have expected result, and you see if they get the expected result. So that will be part of the specification. Yep. Which, by the way, we didn't have in V1. And that is a substantial improvement. Okay, so I mentioned the data model. So in the specification itself, we have a two-pronged approach to the data model. And this might sound a little bit like mumbo jumbo if you're not familiar with the language, but if you're at all familiar with SysML, you know it's a profile of UML. So we are going to have a profile, as you see there on the right, a SysML v2 profile of UML. And so SysML v1 vendors can go ahead and transition to a SysML v2 profile. By the same token, we're going to have a Metamodel that is independent of UML. The profile is based on UML. But the Metamodel will be, in effect, independent of UML. Now, it's not to say we won't reuse portions of UML in that Metamodel, because there is a lot of very good things that we can reuse. But we're no longer going to be constrained by UML in this Metamodel. So the Metamodel itself has, you'll see 3 basic components there. Again, in terms of languages, you hear abstract syntax, concrete syntax, and semantics. So the abstract syntax would be the equivalent of English, would be like nouns and verbs. We have blocks and activities and things like that. Those concepts, if you will, are defined by abstract syntax. And there are certain rules of grammar. So you can't have inputs or outputs going into an activity, for example. That would break, right? That's a grammar rule. So the abstract syntax defines the basic concepts like nouns and verbs that you have in English, and the grammar that goes along with it. The concrete syntax describes the symbols that you see in the model. And the semantics describes the fundamental meaning. It's a mapping to the real world in terms of basically the meaning of the constructs that are defined in that abstract syntax. So the formalism will be around that, and you see there's mappings between them. But the takeaway from this slide is that we'll have both a profile and a metamodel, and they will be, the profile and metamodel will have a mapping between them. So I mentioned on the data model itself that we started with the industry standards, and in particular, I'd refer to the system engineering body of knowledge, the SEBOK. I'm sure some of you are probably familiar with it. So we actually started by doing a mining of the concepts in the system engineering body of knowledge. And this figure is just a piece of that. I don't know if you can see it from back there, but it's just the very high-level concepts that are in the SEBOK. We have a lot more detail than this, but this was sort of the core starting concepts. So what are they? They're things like systems engineering, system. Those are 2 pretty big important concepts. System context, system of interest. You see with system, you see behavior, properties, complexity, emergence, various things like this. So we started with this. We didn't, and we're using it as a high-level framework, and of course there's a lot more detail than this, but it's a high-level framework, and we're basically mapping to it and saying, okay, what of these concepts are we trying to cover in SysML v2? And some of these we're not trying to cover. I'm not trying to deal with, for example, competencies. UAF does, they have concepts like that. But in SysML, we tend to be focused on the system, or even system of systems, but it's more on the basic systems, behavior and structure and requirements and stuff like that. Typical system engineering stuff. So this is serving as a pretty good framework, and we kind of have more or less have a mapping back to these high-level concepts that are in the standards. What we do see is that the standards do not have, at least these standards, excuse me, don't have a lot of detail. So for example, if you took a concept of an interface, which is a really important concept, I'm sure it's probably on another view of this, but there's not a lot of detail behind it, and it's not well defined. So even in our vernacular, interface, we use the term every day as system engineers, but what do you mean? Go check yourself, talk to each other and see if you have the same definition of interface. You won't. So we got a lot of work to do to just nail these concepts. I think we've got a lot to work from SysML v1, but we can do a lot better even going forward. So the basic concepts that we're specifying requirements for are indicated by the organization in this figure. This is how we've kind of organized the concepts. They're similar to how we've organized the 4 pillars, but there are some differences. So you see requirements and verification on the left. So in verification in SysML v1, we just had basically test case and a verification relationship. We're extending those concepts for verification quite substantially. So we have, quite a few other concepts for verification. For requirements, we'll have our typical text-based requirements, but we're also moving to things like property-based requirements. I don't know if you've heard that term, but it's a more precise way to express a requirement. You can use basically equations. So just a very simple example, if I had a mass requirement, you could say the system shall have a mass of so many not to exceed so many kilograms, or you could write that in an expression. So imagine a more complex case than that. You basically start representing these requirements in the form of expressions. So that's a big change. And in fact, it's been introduced in SysML 1.5. We're just carrying it forward to the next step. And behavior, there'll be a lot of similar things that we have today, but some additional things, timing type diagrams and things like that. Structure, doing quite a bit in structure. So we have blocks and parts today. We'll have blocks and parts tomorrow or equivalent. But we're also addressing variant configurations and things of that sort. So there'll be quite a few things that we're doing there. And a big emphasis will be to better integrate behavior and structure. So those two are better integrated. And for those of you who've modeled with SysML, you know that's very challenging. For example, if you have an output of an action and you want to relate it to this port that goes out this port, and there's this item flow and it goes into this, that's a really complex thing to do, right? I mean, there's a lot of work to get that to be just seamlessly work, to get it to be fully executable and work the way you want. So we're doing a lot in integrating the behavior and the structure and so we've got interfaces defined much more elaborately, a lot more with properties, values and expressions. We'll have things like vectors and matrices that will be part of the language. And then there's set of concepts around analysis. So these are some of and there's a common core of common concepts that cross the entire language. Yes?
Would there be, this may reflect a gap in my own knowledge, but would there be any attempt to somehow resolve or bring together the notion of behavioral features such as operations and receptions and the whole activity modeling construct, with actions and activities and whatnot, and so sort of having a more unified construct towards behavioral objects, which I find rather frustrating.
That's considered a major issue, and so the integration within behavior of the different, sequence diagrams and activities and state machines to get that better integrated, but also to get that integrated with structure, basically across interfaces, ports. Those are the two really focus areas. But, and again, there's some really interesting things in structure. We don't have time to go in, but a lot of it is around configurations and being able to define this. Goes back to some of this variant concepts, having variability and then having distinct, unique configurations and being able to support that. So those are some of the kinds of things that we're doing. So I'll just to reiterate some of those, just a bulleted list of a few of the things that I just mentioned. Timelines on the behavior side, we've always wanted those, but much better integration with analysis. We've made a lot of progress. Terry, you mentioned the use of parametrics. There's a lot of analysis concepts. For example, today, we don't have a concept called analysis in the language. We have a concept for analysis in SysML 2. We have the parametrics and all that, but now you can set up, define an analysis and use similar patterns, but they're going to be much more robust. We've done a fair amount of work in that area. We're going to have simple geometric concepts of shape and coordinate systems, primarily with the intent of specifying envelopes, physical envelopes. We feel that's just really important to include. I mentioned that and some other aspects. Just to, yes?
I have been struggling with the concept of priority. So this, you know, in our case, it's an FAA model, and if they give a command, you have to do something. But if they give you an advisory, you need to listen, but you may or may not take action. And I can't show, or haven't figured out how to show, and how to make the command more important. It doesn't necessarily tie to timing. Is there anything that'll help me with that?
I don't know, not offhand. I mean, that's something, you know, I think that's in part done by your for example, if it's in a real-time software sense, it's scheduling algorithms and things like that that deal with that. So it's more built into the algorithms themselves. We are going to take a look at that. We still have a shot. I'm actually having a presentation on sort of software architecture and some of the real-time concepts at the next OMG meeting, and we're going to kind of see to what extent we have gaps and if there are some things that we need to do to provide coverage for those. So that might be an example. But there's a whole set of software architecting concepts, you know, all of the embedded real-time type concepts that
wants to see it
at a system level. Yep. And
allocated to software that's not.
yeah, it's a good point. It would be a good thing to take a look at. And
Just asking.
yeah, I have to think about that. I'll be looking for that when we have that software concept. Like a lot of software concepts, you can abstract them up to system level, but put a little different spin on them, and they have a lot of significance, you know. But at any rate, I mentioned model construction. So this is Ron Williamson sort of led the capability for model construction and defining the services, and they're relatively straightforward, but he used this to just illustrate some of the concepts for model construction and the services that I mentioned. So when you construct a model, let's say this is a very high-level process. It's not down at a detailed, granular level, but it still illustrates some of the ideas that we would want to leverage in model construction. So there is some model management services. So it says log in, and then it says import requirements. So are there services that would enable you to import things? Yes. Then let's just say, and you can do some batch import and transformation. Analyze your requirements. Might be some execution that you do there. Then you see these next three activities. You select your reference architecture variant. So there's a bunch of concepts for that. But from a model construction perspective, he's referring to a library of reference architectures. So we're trying to reflect this thinking in the construction services. And then integrate and configure your components and evaluate your architecture. You see some other things like component libraries, execution. You see something called apply patterns. So patterns become something there's services for defining patterns, applying patterns, et cetera. Commit to service, back to some model management services and the like. So it's very, very high level. It's just kind of used to illustrate the kind of things when we talk about some of these services, the kinds of services that you might need. And he's got some elaboration of that in those bullets there. On the visualization side, one of the real things we're doing, you see the SysML diagram in the center top, and we have the 9 diagrams. And of course, we've gone way beyond that. Extensive use of tables, tabular data. There's a lot of other visualizations in most of the tools now. There are advanced graph visualization tools out there by at least one of the vendors that's very powerful. So there's been a lot done. What we're illustrating here is just various views of this model that we'd like to be able to support in SysML v2. A much richer visualization experience beyond just the diagrams. We're going to maintain the diagrams, we're going to keep them there, but we're also going to have much broader set of visualizations. The key component for this is the notion of view and viewpoint, which we have in SysML v1. We've had it from the beginning. But what we've found is that concept of view and viewpoint is turning out to be very, very rich. It comes, and if we build that in from the beginning and taking into account what we've learned to date, we think we can do a lot by having a very flexible view and viewpoint mechanism. So you can present data in many different ways. So we'll have our standard diagrams, but as you can see from this, our intention is to have many more. Now, the actual solution to this is going to depend on the submission teams. These are concepts. We'll see what actually comes out, but there's a lot of aspects of this. So now I'll just transition over here to the sort of this architecture. I mentioned the system modeling environment up front. And if you look at it from one perspective, you could see this layered architecture where you have this, the user, basically there's a GUI that he or she interacts with to the modeling tool, for example. And then there's an API to access the services that I've been referring to. So the standardized API would give you a standard way to request those services for doing the kinds of things that we've been talking about. And then, of course, that would access the data, which is your model data, and sits on top of some platform. So sort of a standard layered architecture view. And other plugins would also, and external tools would also interface through this standardized API. So we'd have just nice, clean way to get at the data and to operate on this data in various ways. And then extensibility is really important. So there's some set of services that enable you to extend this environment. And that's part, we have requirements for that as well. So this is basically a high-level view of the architecture. Now, and again, the emphasis here is on that standard API. This is another view of the architecture, sort of a logical view of the system modeling environment. And you see the system engineer and other consumers sitting out there, those little actor symbols out there on the left. And the model repository is over here on the right in that light blue, or turquoise, whatever color that is. And so the system engineer and others are both updating that model and viewing that model and doing things with that model. And there's the API in the center that reflects that previous slide. So we're talking to that repository through the API. Those blocks in between there are various logical components that the vendors will implement. That's up to them. They implement those components in various ways. Some vendors may choose just to implement certain of those services, and others may take and implement, a whole set of all of the services for that matter. So anyway, it just gives you a flavor, and the external tools are sitting there over to the left. It's a little bit hard to see in this with this slide. But anyway, it just gives you a sort of a logical view of this architecture. So what is SysML2 specifying once again? That model in the blue, the data model for that, and the services on that API. That's what the specification is. Vendors then would implement that in their tools. Yeah, I'm just about got just a couple more slides and I'll wrap up. Okay. So just a couple of things about kind of schedule where we are, and I've mentioned the RFPs coming out at the end of the year, but we did start back in 2015. We've had a couple of Incose articles. One was this article back in 2015, August, which laid out the driving requirements for that system modeling environment. And then in December of this last year, we had the concept that I just showed you, and a pretty elaborate article on the concept for the system modeling environment. Had some of the figures that were in here. And we had presented this at Incose And where we are right now is we came out with the draft requirements in June. And we're right now going through a fairly extensive review process. And we're going to get collecting up comments and fold them back in. And basically, we'll present that draft RFP to the OMG in September at the next meeting. So it's out for review, more or less kind of industry level review right now. So not per se through the OMG, it's external review. And so we've got, you know, a fair number of folks that are looking at the requirements, and I'm looking forward to getting their comments. And we'll issue it in December and form the submission teams and go. Probably take a couple of years after we have the requirements to get the language. But we don't wait for it. The vendors actually start implementing the stuff kind of as it comes. So it's not like you have to wait a couple of years. And this process is very informative. Just going through this, I think, is helping, I would like to think, is helping the community to coalesce around some general directions that we're heading. Later sounds good. So just to show you, these are the way the requirements are organized in the model. I won't go through those, but the services and the data model and all that. And I'll just finish up with this slide, and then if we got a couple of minutes for some questions. So SysML v1's been out there for over 10 years. By the time we get there, 13, 14 years, when we get to SysML v2, we feel like it's been an enabler of MBSE. As I said, we understand where it's strong, where it's weak, and that's given us a good solid foundation from which to move out on this next generation. And we are specifying SysML 2 in the context of a system modeling environment to support MBSE, and we want to think about MBSE over the next 10 years, 10 plus years. I mentioned the 3 areas that we're focused on, and the spec itself will include this Metamodel, the profile, set of model libraries, the standard API, this notion of a very flexible view and viewpoint, reference models, test cases, et cetera. And very importantly, it's the last bullet here, but I didn't say anything about it before. We're going to, there's a hard requirement to be able to migrate from SysML 1 to SysML 2. So you don't lose your investment in going forward. So that's pretty much it.
All right, well, thank you.
There's a couple of references here at the end.
Right.
And
I'll ask the first question, then other people need to use the microphone. We'll have about 10 minutes. In the first area, you had the integrated teams, integrated system engineering teams. That seems to map somewhat with Agile. I know it's a little bit of a different concept, but I think you can map it into Agile. Is that any idea from you?
I mean, there's been a lot of discussion about just MBSE in general, and is it, you know, consistent with an Agile approach? I personally believe it's very consistent with it for a variety of reasons. I mean, you get your data integrated and you can, you know, move around much more quickly. I mean, you still need very serious planning, but all of the basic like Scrum type principles, I mean, you could apply those. And in fact, you know, we have in part of the OSM working group, which is out of the Chesapeake chapter, they're actually doing some work with Agile techniques right now and integrating them with MBSE.
Right, I just didn't want
Mike Pafford, if you know Mike,
yeah.
he's kind of leading that up.
He's our president of the Chesapeake chapter.
Okay, yes.
Yeah, I just wanted to make sure that people understood that Agile would fit in there and wouldn't be exclusive to the integrated teams.
I think modeling in general, it's very rigorous, or it can be and should be rigorous. And so it requires a lot of discipline, but it also has the potential to be, you know, quite agile. And you can adapt the level of detail and fidelity to your needs. So if you're early on in a concept, you can do conceptual level. And if you're more detailed, you do detailed. It's precise. It's intended to be precise. But I don't see that it in any way, I think it facilitates Agile, in my opinion.
And I think one of the points is that people don't get that Agile does have a lot of structure and process to it. It's just not wild stuff there.
Right.
But it's really detailed, and you have to follow a process and data
Yeah.
structures.
Yeah. Yeah, okay.
Okay, next question, anybody?
Yeah, several years ago, Dr. Francis, he was Penn Civil Systems, and then he was at Cornell back in 10, and he came and talked to the Delaware Valley Incose, and he was talking about how many, when he was working big contract for Corning, looking at all the different programs where they use the system engineering process and not, and they had a lot of metrics, about 27 programs where it was successful. So in the metrics on this, from all the way through version 5, when they apply it, this works on large programs, and economies of scale. Have they looked at all the costs, in prepping for big programs? I don't know. I didn't think they did that on the Ford Carrier, but how are the metrics and the uncertainty involved? When you do the planning and the actual process.
If you're asking, are there metrics available?
Yes.
For programs that have applied MBSE? Yeah, I mean, there's, if you go to the MBSE wiki, there is a methodology and metrics page, and there's a metrics, specifically on the metrics page, there's a lot of papers on that. It's broader than SysML. I mean, it's model-based approaches in general. And they talk about, it's very hard to get real quantitative data, but there's a lot of qualitative data out there. And I think when it comes to quantitative data, a lot of times either organizations don't have it, or if they do have it, they don't necessarily want to share it. So it's hard to come by. I have seen some pretty compelling metrics data myself, some of it, I would say most of it internal. I will point out one, though, that is interesting. There is a case study in the SEBOK now that is called SWIFTUS. It's around SWIFTUS, which is a submarine warfare tactical federated system. Steve Mitchell was the author of that case study from Lockheed. He's a colleague of mine. And the Navy agreed to let him write up this as a case study for the SEBOK. And they do have metrics and ROI. It's not, I wouldn't call it crazy incredible or anything like that, but it's, I think they were 6 and 10% type improvement numbers, but they don't get at all the benefits that they've gotten from that. I mean, it's certain efficiencies that they've gained, but there are other efficiencies that were much more difficult to measure. So I suspect if we looked hard, there might be additional benefits. But you'll hear anecdotally a lot of cases where there's been substantial benefits and places where it hasn't. So you have a mix. But where it's been applied, properly, and you have the right expertise and everything, I think you see some real compelling cases, but not a lot of hard quantitative data.
Yeah, I know in Northrop Grumman they had the integrated enterprise process, about 2000, and it didn't cover all the supportability disciplines.
Right.
But they did that like on the E2D and some programs.
Okay, but again, if you refer to the SWIFTUS case study, I don't think it's in the case study itself, but it's in some of the papers that Steve has written. I'm almost sure that data is there. I've seen it, and I'm almost sure it's publicly available. Yeah. Any other?
This is Harry Windsor. How about how this whole process interfaces with a real top-level thing, like how to prevent war, or how to improve health in a nation or in the world, or how to categorize stuff at the level to prevent or to respond rapidly to epidemics, all the things like this. What kind of interface is there at that level, and how valuable might that be?
So, I mean, that's a question for system engineering, and applying it to these, socio-technical systems is sometimes what they refer to. These broad societal type systems, as opposed to here's a hardware system, here's an aircraft, here's a submarine, here's an avionics system, whatever. Those are sometimes, if you use the term socio-technical, they use that in SEBOK. But it's system engineering applies. There's nothing that precludes these concepts from being, modeling concepts, from applying to those kind of concerns as well. I mean, prevent war. I mean, that's a pretty nice challenge. There are a lot of good system engineering. I think the modeling could be applied to that, just like you use any good system engineering.
Well, another specific thing is the Club of Rome study, and the sort of things that can be done with global modeling, and of course climate fits into that and so on. How do we get systems engineering in there to especially clarify the validity of the various concepts that people use to try and limit the budgets so that they don't happen on their watch, and their plans can go forward, and stuff like that?
I don't know. I just don't know. I mean, those are huge questions that I think go way beyond what we're trying to do here. I mean, those are tough questions, right? And I think I don't know that the model is the central theme for addressing those questions. I think modeling can help. We have a project kicking off right now in the OSM working group, coupled with the Critical Infrastructure Protection and Recovery working group, that's about the national infrastructure, and we're going to actually try modeling, starting with what are called microgrids, and we're just kind of kicking that off. So that'll be a good opportunity to see how it could help, and various kinds of threats to electromagnetic pulse and all the various cybersecurity and all those kind of things to the national grid. So that would be an example, which would be of the sort of the scope that you're talking about. I think I personally am a big proponent of system engineering being applied to those kinds of systems, and I think it makes perfect sense, but we got policy folks to deal with and what have you. That's a bigger job than this modeling. We have a challenge to do that. It is something we emphasized in the System Engineering Vision 2025. You'll see that emphasized there as we move forward with system engineering as a discipline and how to bring it to bear on these kind of problems.
Okay. So in summary, it's something you're not ready to tackle yet.
I think it's not so much from a modeling perspective. I think it's just a bigger question than the modeling. If somebody's ready to tackle it, I think we'd be. I would say, sure, use modeling, system modeling to support it. So if you're running with that, I'd say use modeling. See if you can bring it. I think it could bring a lot to bear. That's what my answer.
All right, thank you. And thank you, John Hopkins and APL, for bringing us the facilities and the capability to have you here, and we hope to bring you back again to give us an update. At the moment, we've got the book that you're one of the authors. One of the authors. So we go raffle it off.
Okay. A picture? Okay. Oh, okay.